Okay, so welcome. For those who are new to this whole thing, Robot Mesh is a software partner and authorized VEX reseller. We also have a programming environment for all the VEX robots, which is Robot Mesh Studio. And we do support with teacher development and curriculum. So we also support teams, event partners, and school teachers who want to do VEX but are unsure of where to start. In this session, we're going to be covering what is Python and why you should choose it. Where is it used in real life? Because there are a lot of awesome real-world applications for this programming language. Then we will look at garden variety Python, which is the basic syntax. And finally, we will step into the idea of object-oriented programming, which will be a new thing if you're coming from a language such as Robot C. So what is Python? Python was developed by a guy named Guido van Rossum, and he actually named it for the Monty Python comedy troupe. It's quickly becoming one of the world's most popular programming languages. So I'm a huge fan of it because I like being able to move my students from VEX into the real world. And well, Robot C was a great language and ModKit's a great language. Unfortunately, nobody in industry is programming in any of those languages, whereas they are in Python. In fact, the Institute of Electrical and Electronics Engineers currently ranks Python as one of the fastest growing and most popular programming languages in the world as of 2018. The primary reason for this is because Python can accomplish many of the same tasks as other programming languages using far fewer lines of code. Therefore, the chances of introducing bugs into a program is much lower. You'll find that the syntax of the language also closely resembles typed English. The big idea that Van Rossum uncovered when he was developing Python is that code typically gets read far more often than it is ever written, and usually by others who may not have written the original program but who now must maintain it. So part of the push towards making a program easy to maintain is this strong focus that Python has on readability. So let's take a look at some examples of how Python differs to other languages. And I think you'll quickly become a fan of Python once you see. So for many of you who've done this style of text-based programming before, it's very common to write a program that does nothing more than write hello world to the screen. In the above example, we can see this as a C program with the very familiar curly braces. In the middle, we see it as a Java program. And in the bottom, we see it as just print hello world, right? So what C does in 1, 2, 3, 4, 5 lines in Java, and 1, 2, 3, 4, 5, 6, 7 lines, Python does in 1. And for me, this was really awesome when I first saw how English-like the language was, because when I was in college learning how to program, my professor said, I want you guys all to print hello world to the screen. And I remember asking, well, what do these other 8 or 9 lines do in the program? And he said, don't worry about that now, just type it as you see it. And if you make a mistake, like you miss a semicolon or an opening or closing brace, it can be very frustrating because the logic of your program will seemingly be all there in your head. But because there are so many more lines to type, the likelihood of introducing a typo is far greater. So Python is an all-around great beginner's programming language, very much in the spirit of Pascal and BASIC and those old languages from back in the day. Here we see a second example of Java versus Python. And again, what Java does in 18 lines, Python does in 4, which is really quite incredible when you think about it. So who uses Python? Python is used at Google. In fact, if you get hired or in the process of getting hired at Google, it's very typical that you'll go through your programming interviews doing Python questions or doing coding sessions using Python. YouTube, by extension, also runs on Python, Instagram, Dropbox, Reddit, Spotify. The better question here is, who amongst the big Silicon Valley tech companies isn't using Python? In the VEX context, both VEX-IQ and VEX V5 EDR, as well as the old Cortex, can all be programmed using a Python and Robot Mesh Studio. As of this summer, the Python programming is exactly the same for VEX V5 and VEX-IQ. If you are using the VEX-IQ, you'll want to select Python Beta as your programming language when creating the project. And we'll go through that process a little later on so you can see where that is. If you are completely new to programming and are horrified at the idea of learning Python, we can see here that this is Google Blockly. Again, it looks very familiar to ModKit. And it generates Python. So you could build your program as a Blockly script, and you could actually see the generated code in a different window. And maybe perhaps we'll take a look at some examples of how to use Blockly in that way. In fact, I like to say that Blockly is actually the help system for Python, because if I don't know a Python command or I'm not sure how it's structured, I can always go into Blockly, pull out the blocks, and see what the generated code is for it. So what I'm going to do right now is I'm going to step into creating a Python project in Robot Mesh Studio. If you've never used Robot Mesh Studio, it's freely available from www.robotmesh.com/studio. All you have to do is install a Chrome browser extension. There are two styles of projects that we can create within Python and within Robot Mesh Studio more broadly. One is we can write programs for the physical robot, which we can see here with the IQ, V5, and VEX EDR Cortex. We can also create something called a mimic. And what a mimic is it's a simulation. And so for the first couple of projects, I'm going to be working in the simulation or the mimic environment, just so I don't have to keep downloading and chasing my robot and going back and forth between my computer and the physical hardware. A little later on, we'll look at some examples using the physical robot, so stay tuned. Okay, so I'm just going to temporarily bring a window here into the big screen, and we'll take a look at creating a Python project. So let's go to robotmesh.com/studio. Okay, so if you've never used Robot Mesh before, going to this web address will give you an opportunity to create an account and install the Robot Mesh plugin. If you do not create an account, you can still use Robot Mesh Studio. It's just that you will lose your work when you close the browser. So if you want to save your work and have it sitting there for the next time around, I highly recommend creating a free account. If I come over here, I can create a new project. And the first question it's going to ask me is, what is my target platform? So you'll recall earlier I mentioned that there's two styles of projects, mimics and projects for physical robots. To start with, I'm going to write a project for a VEX V5 mimic, or a simulation of a V5 program. My programming language that I'm going to choose here is Python. This is where the Blockly person would choose Blockly. And then under options here, I can give my project a name. So I might call this Hello World and hit create. And what I'm going to do right now is I'm just seeing here on Facebook that I seem to be missing my screen share. So I'm just going to close my PowerPoint temporarily here. And let's go to I'm going to reshare this screen so that we can see what's going on here. Okay, so again, if somebody in the chat window can just say, I can totally see your programming environment, that would be awesome, so that I don't leave anyone behind. I will just hang out here for a second to make sure that everybody can see this. Awesome, thank you for telling me. Thanks, Wendy. Okay, so here we are in Robot Mesh Studio. Robot Mesh Studio, the editor is divided into a couple of different windows. So we have here on the left a description pane. We might think of this as kind of like being like your engineering notebook. You can just make notes, put pictures, type stuff in. So you might have your student document their design in here. The windows themselves can be resized. So you can see that by taking my left mouse button and dragging it, I can resize these windows. I can also use these little hotspots to maximize and minimize windows. I have my program editors, the next window where we're going to be writing our Python code. I have a mimic window. So if I had actually built a 3D simulation of the robot, I would see it here and I could program and control it here. I have here on my right-hand side my device monitor. So as I begin to work with the real robot or the simulated robot, I will start to see my different smart motors and sensors plugged into these ports. And then finally, and of most interest to us, is in writing Python, occasionally we will run into errors as a result of typos or just bad program logic. And those errors and output will be displayed here in this bottom window, which is our terminal window. So let me go back here into the code window. I'm going to make this a little bigger so you can all see what's happening. And I'm just going to write a very simple program, which, in keeping with tradition, is going to write hello world. So I'm going to write the word print. And you can see how when I type print, how it highlights, it turns pink, letting me know that it's a special keyword that means something to the Python interpreter. And then I'm going to write hello world. And I will hit run to run this program in my simulated file. So let's hit run, see what happens. So my program runs, and then down here at the bottom, it writes hello world. Now I could add to this program. I could add another print statement. I could go print, thank you for attending my webinar. Now this time around, I've used single quotes, and that is also valid in the version of flavor of Python that we're using for the VEX robots. The key idea here is that whether you use double quotes or single quotes, that you close using the matching quote. So if I run this code, it will now say, hello world, thank you for attending my webinar. Going further, I could use brackets. And if you have done any programming in Python 3, you will recognize that in order to use the print command, you have to use parentheses. Now, does it matter whether you write your text in parentheses, single quotes, double quotes? In our version of Python, which is running on Python 2, it doesn't matter. If you are new to Python, I would encourage you to build good habits and get into the habit of writing everything using these opening and closing parentheses. And that's because eventually Robot Mesh Studio will move to Python 3. Right now, the thing that's holding us back is the amount of available memory on the VEX IQ robot. So what you might not appreciate is that the older VEX Cortex didn't have gigabytes of memory. It didn't have megabytes of memory. It had K, like 64K, as in like your cell phone was like 100 times, thousands of times more powerful than the computer that was controlling the old Cortex. The IQ is a little bit better, but there's still not a lot of memory. So in order to get the Python interpreter to fit, we had to go with Python 2. Now, the good news is that there isn't a lot of difference between Python 2 and Python 3. All that happens is in Python 3, some things become more formalized. So this print statement becomes a function, so it has opening and closing parentheses. And if you were to type hello world, or the second line here, thank you for attending my webinar, without these parentheses in Python 3, it would throw an error. But for right now, we're good. I'm going to hit play, and we can see it says hello world, thank you for attending my webinar, and then use parentheses. Now, for my ModKit person in the room who's scratching their head saying, how would I have done this in a block-based language? I'm going to open up a second tab. And again, I'm going to go to robotmesh.com/studio. I'm going to create a new project. Again, my project is going to be a VEX v5 mimic, just like the last project. This time, instead of choosing language as Python, I'm going to choose Blockly. And for now, I'll just create this as the cutesy name that they give me, which is Heavy Car, and hit create. Okay, so here I am in a Blockly program, and what I'm going to do is I'm going to go into Robot Mesh, and I'm going to write print hello. Okay, and here I will hit play, and it's going to print hello here at the bottom of my screen. What it also did, though, is you can see I have a tab here called Generated Code. And what it did is this is the Python for the project. So for Python people, if you didn't know how to do something like, say, for example, I want to create a loop. Let's just, and maybe I want this, I don't know, this loop is going to loop forever, and it's going to print hello forever. You can see how it generated the Python here. So later on, what I can do is I can actually come in here to my options in the top right-hand corner and click copy project. And I can go from this being a Blockly program, where if I change the project type from VEX V5 Mimic Blockly project, I can go to something like a VEX V5 Mimic Python project and hit OK. And what will happen here is it will now get rid of that Blockly window and it will give me an editable Python window. So that is Python, the just garden variety print statements in Python. Let's take a look at what other goodies I have here in my PowerPoint. So I'm just going to come back into the PowerPoint presentation. And then we'll stop in a couple of minutes here for some questions if anyone here has something that they'd like to ask. So let's come in here. So I'm just catching up here in my presentation. So let's take a look at some other things here from current slide. So for those of you who have worked in a language like Robot C, you'll know that when you declare a variable, which is just a bucket holder or a placeholder in memory, that you have to use a keyword such as int for integer. I think it is double for a real number or a decimal number. And then there's other keywords that you have to use. In Java, there's things like an str for a string and so on and so forth. Python's a little different. It's called a dynamically typed language, which means that variables do not have to have a data type declared ahead of time. So we'll see what that means here. This is an example of creating a variable in Python. So here I have a variable called my_robots and it equals 2. And then using that print statement, I'm able to print the value that's stored in my robots to the screen. So you really can't see it down here, but it says 2. And then what happens is a little later on in my program, I can do something such as make my robots equal to a text string. So I might give my robots a name, which is R2D2 and C3PO, and print my robots. And now what will happen is it will actually print that value as a string here in the bottom of the screen. That is something you cannot do in a language like Robot C. You'll get an error, but in Python, you can do it. Where you will get into trouble with a dynamically typed language like Python is if you try and do math now to the string. So if I went and I took R2D2 C3PO and I divided it by 4 or did something goofy like that, I would probably get an error from the Python interpreter. When naming variables in Python, there's a couple of rules to use. Variables in Python always start with a character, such as a letter. So basically, you can have lowercase a to z, uppercase a to b, and you can also use numbers and underscores in your variable name, but you can never use a number at the beginning of a variable. So here on the left, we have a collection of valid variable names, such as my robot name, my robots, robot name with a capital N and a number 2. And on the right-hand side, we have number 2 robot name. If I try and declare a variable using a number, it will actually throw an error at the bottom of the screen saying that I've messed up. So here I've created a variable called 2 my robots. I've called them Rick and Morty. And now the Python interpreter complains about that code when I go to run it. Assignments, use of the assignment operator setting the variables is pretty straightforward. Just like in other languages, you use an equal sign. So here we have the variable x and a variable y. I've set the variable x to equal 5, the variable y to equal 10, and then I've set x to equal the value contained in y. So now when I go to print both of these variables, we're going to see x equals 10 and y equals 10. So that part should look pretty familiar if you've done programming before in Robot C. Here's a math example, which again is taking these variable names, which I've created, which is addition, subtraction, multiplication, division, modulus. For those who don't know, modulus will return the remainder of a number. And then I have my exponent. So I could do something like 2 to the power of 3. And here what I've done is I've taken my x and y variables and I've done math with them. So I've added them, subtracted, multiplied, divided, did modulo, and did it as an exponent. So 5 to the power of 2. And then what I've done here is I've printed the output to this screen. So again, that will look pretty familiar if you've done programming in other languages. I just wanted to show it in a Python context. And then what we'll do here is, I think I'll introduce the idea of data types, and then we'll hang out for a couple of seconds to ask questions. Data types in Python are basically, we can have integers, which are whole numbers. So here I have 3 variables called games played, games won, and it should really say games lost, not games lost. So these are all whole numbers, 12, 1, 11. I have a variable that is my first name and my last name. Again, note that we're not declaring the type of the variable. So you're not seeing an str here. You're not seeing an int in front of these variables. I also have a float, which is a decimal number. So here I have robot height in meters, robot weight in kilograms. And then finally, the last data type that we'll talk about here is Boolean values, which are basically just simple true or false values. Of course, Python supports other data types, more advanced data types. We're not going to go into them in this lecture, but if you wanted to use them in Robot Mesh Studio, you totally could. So what I'm going to do right now is I'm just going to stop here for a couple of seconds. And if you can find the Q&A button, I'll hang out here for a couple of seconds so you can ask questions, and then I'll read them on air. And if you can't find the Q&A button, I'm also watching the chat room window, and I can look for questions that are in there. So take a second now and give me any of your questions, and we'll just hang out here for a minute or two. For those of you who are watching this presentation on Facebook Live on our Facebook channel, if you throw your questions in the comments, I may or may not get to them during the live session, but I will certainly answer them when I am done with the webinar. So you can also leave your questions here in the comments window for Facebook. Okay, so I haven't seen any questions yet. If you come up with something you want to talk about, do throw your question in there. I'm going to move on now to more interesting things. Like, let's take a look. What is more interesting than data types? If statements. So for those of you who've done programming in Robot C, you'll know that when you use an if statement, you typically have opening and closing curly braces. In Python, the key thing here is not the use of braces. In fact, you'll never see curly braces in Python. What you do see, though, is indentation plays a big role in Python. So the Python interpreter will look at this if statement and do an evaluation. And if this condition is true, any of the things that are supposed to happen when the condition is true will show up in the indented text. So if I mess up my indentation, for example, I don't indent or I indent too far, I'm probably going to see errors in the Python output window at the bottom of Robot Mesh Studio. So let's take a look at some examples using the if statement. So the easiest one is just to say if true, and basically that's me using a Boolean value. You'll notice that true here is using the capital T, and it's all in pink, meaning it's a keyword. So it's going to say if true, colon, indent, print it's true. So because this is always going to evaluate to true, because I've been explicit in telling the if statement that, it's going to write it's true here at the bottom of the screen. If 3 is greater than 2, colon, print it's true. In this case, 3 is greater than 2, so it's going to print it's true. Let's play around with a variable called hungry, and we're going to set hungry to false. Note that false here has a capital F and is highlighted in pink. So if hungry, so if I'm hungry, if that's true, we're going to print feed me. Else, so else is our default case. So if it's not true, this bottom condition is going to execute, print I'm full. So because hungry is set to false, the top condition never executes. Instead, this bottom default case executes, which is indented, and it says print I am full. Let's look at a more sophisticated if statement here. Here I'm going to set my location to equal the word bank. And we're going to say that if the location equals bank, and so here this equality operator, which is what it's called, there's two equal signs, is different than what we call here the assignment operator. So when we use one equal sign, we're saying, hey, variable, hold this value. When we use two equal signs, we're doing an equality comparison. So we're seeing if the value contained in location equals bank. So in this case, it does. It says if location equals bank, print I love money. And so it writes I love money. Then we have else ifs. So in Python, they're called elifs. So here we get several other conditions we can test for. And finally, a default condition that executes if none of the above conditions are true. So let's take a look at some of these other conditions. I've changed now my location to equal home. So we'll test for that. It says, if location equals bank, print I love money. Well, location does not equal bank, so it's not going to print that. It's going to say else if location equals work, print I hate work. And we're not at work, so it's going to go down here. It's going to say else if location equals home, print I am sleeping. And so it prints I am sleeping. Now I've changed the value of location to be something that is not one of our test cases. So here I've changed location to equal Seattle. So if location equals bank, it doesn't equal bank. The location does not equal work. The location also does not equal home. So none of these above three conditions are true. So my bottom case is going to evaluate, and so it's going to say print I am lost. And so when location is Seattle, I am lost. While loops look very similar in Python. Again, it's using a test condition, the keyword while, and a colon, and then some indented lines that form the code that gets executed within the loop. So let's take a look at some examples using the while loop. Here I have a value. I'm just going to call it my counter. I'm going to set it to 5. And what we're going to do here is we're going to say that while counter is greater than 0, so as long as this is true, 5 is greater than 0, then print the value of the counter and subtract 1 from it. So when I run this code, it's going to go through the first iteration of the loop and say, is 5 greater than 0? Yes, it is. Print the value of counter. So here we see counter equals 5. Then we're going to subtract 1 from that value. Is 4 greater than 0? Yes, it is. Is 3 greater than 0? 2 and 1. And finally, 0 is not greater than 0. So this condition is no longer true, and we kick out of the loop. And so now the program ends, and we can stop and reset the mimic. For loops have a slightly different syntax. In Python, a for loop uses something called an iterator. And so basically what it does is, given a set of values or a range of values, in this case, it will iterate through each value in that list. So for example, here I have a variable that I've made up called I for index. And I've created a function that is going to generate a range of numbers 0 through 4. And so for each iteration through that list, so in the beginning, I is going to equal 0, and then it's going to print 1, 2, 3, and 4. And finally, it has printed all 5 values, 0 being the first value, and it's going to terminate. So let's take a look at some real-life examples using for loops, and then I will hang out to see if anyone has any questions. So here I have a string, and I'm just going to give my string a name. My string is going to be called Sammy. And so for each letter in Sammy, in the name, which is Sammy, I want you to print the letter. So what's going to happen is it's going to print the first value, which is S. So it prints S. Then it prints A, M, M, and Y. So here, this is the 0 index, the 1, 2, 3, 4. And then when it is done iterating through that string, the program completes. So for loops are a little different. If you've used other languages like Java or C++, you're probably used to doing something like for int I equals 0, for I is less than or equal to some number I++ or something like that. So you have a bunch of conditions that you're testing for in your for loop. In Python, we're using an iterator instead. And again, if this is kind of a wild idea to you, there are going to be some examples on our YouTube channel of how to do this within Robot Mesh Studio. So don't freak out. Okay, when working with a for loop, I can use the keyword break, which breaks out of the loop. So here what I can say is I'm going to iterate through each character in the name. And if the letter equals, so here I'm using the equality comparison here, equal. If it equals A, then skip that letter. So here what it's going to do is it's going to print the letter S. It's going to come to A. And if the letter equals A, we break out of the loop. And so what's going to happen is all it prints is the character S. So you can see here that break is a special value. It shows up in pink. It's a keyword. And then we can use the keyword continue to skip that iteration. So here again, using the name Sammy for a variable called letter, which I've just made up in name, it's going to skip through, when it comes across the character A in Sammy, it's going to skip that iteration. So here it goes S, it skips the A, and then it prints the other characters in the string. And that's using the continue keyword. And so here's another example of using loops. Here I have what is called a list, and it contains various types of animals that could be pets. So I have cats, dogs, rabbits, and hamsters. And so for my pets, which is a variable I'm declaring in pets, print the value inside of this list. And again, we won't get into lists today. It's kind of an advanced data type, but it's a way that we can store a sequence or a combination of different data types all in one variable. Okay, so before diving into the deep end with object-oriented programming, which is going to be new to you Robot C folks, I'm just going to hang out here, and if you want to throw any questions you have at me in either the Q&A or the chat window, I will hang out here and we'll answer whatever questions you may have. People who are following this on Facebook Live, if you leave your questions in the comments section, I will likely come back to them when this webinar has concluded. So I'm just going to hang out for a minute. And if you have any questions, please take a moment now to type it into the question and answer box in Zoom meetings. So I see some of the folks on Facebook Live are asking if we can get a copy of the webinar. The answer is yes. I will be posting the link to the webinar once it's uploaded into YouTube. So just hang out. This is gonna be a real mammoth-sized file, so it's gonna probably take me an hour to pull down and render. So very likely sometime tomorrow, there will be a new video posted to our webinars playlist. Wendy asks, how do you set up your motors and sensors in Python? Excellent segue to what I'm about to talk about, Wendy, which is going to be object-oriented programming. And we are going to begin working with the real robot now. So what I've just demonstrated is that you can actually use Robot Mesh Studio just to learn garden variety Python. And so it's an awesome tool for learning the language in general. We're going to take a look now at how to program the physical robot's motors and work with its sensors, any peripheral devices that we have hooked into it. So the basic idea of an object-oriented language is you have a thing called objects, which are basically nouns, persons, places, or things. So an example of an object might be a motor, might be a robot, might be the V5 brain or the VEX IQ brain. These are all nouns, right? They're all things. Methods are, we can think of them as verbs or actions being performed on the object. So a method might be like, an action like spin. So we might say motor, which is my object, and then we might go dot spin, which is my verb or action being performed. Inside of the parentheses, what we can do is we can pass additional data that the object and method need to perform its task. So for example, if I take my motor and I tell it to spin, I might want to tell my motor how fast to spin or for how long to spin, or to brake or hold the motor in a certain way when it has finished moving. And we'll take a look at many examples now. But for right now, just to use a generic example, let's think about the idea of a dog. So a dog is our noun. It's going to be our dog object. And so different types of verbs, different types of methods that can act upon the dog is we can set our dog's breed. So our dog might be a German Shepherd. Here we can see dog.setBreed German Shepherd, or dog.createName Fido, or dog.bark. You can see that in the parentheses here, in certain cases, we're passing a value or additional data that the method, the action part here, needs in order to complete. So these methods here would be expecting some kind of string. Bark might not be expecting any kind of string. It's just going to cause the dog to make a sound. So other methods might be rollover, sleep, setBreed, which we've discussed. And then the data we want to keep about our dog, which is its name, its age, its weight in pounds. So let's take a look at a different object, which is a student object. So a student is a noun, right? It's a person, place, or thing. And then there's different actions that the student can take, such as walking to school, studying for a length of time, writing a test. So in these examples here, we have student.setMathGrade, which is our action, and then we're passing it a value, which is 78. Inside of this, there might be variables that we want to hold onto this value. So for example, we might have a math grade, we might have a student number, a grade point average. Here in the second example, we see student.writeTest, and then we're telling the method how long that test should be in terms of the number of time units. This is a VEX V5 command. I'm going to be going very shortly into the robot mesh editor and doing some live examples. So for now, I just want to talk about the theory here. This syntax is going to look very similar for the Cortex robot, and if you're using the VEX IQ and you're using Python beta, these commands are going to be virtually identical. So here I have a variable, which is my left motor. I've called it motor left. I have an object, which is VEX, which is just the VEX system. And then I have a method, which is like some kind of action that the VEX system is going to do. So for example, maybe I'm going to make the motor on port number 1 spin at a certain distance, right? So here we can see the different parameters that we're passing to this method. So for example, motor 1, which is my object, is going to spin. And then this is the additional data that the command needs to execute. So what direction should we spin in? We should spin forward at, say, 20% power, okay? So object, method, parameters, or noun, verb, and then additional data needed to make the motor spin. So let me go into Robot Mesh Studio and do some live examples here. So I'm going to go up into this, into my root directory. And again, what I want to make sure is, can somebody in chat say that you can see the programming environment? I want to make sure I'm not leaving anyone behind. So just say yes if you can see this screen. Yes, awesome, okay. So let's create a new project. This time, instead of it being for the Mimic, which was our simulation, let's create it for the physical robot. So what you can see here, if I go into share, just let me play with my sharing, is okay, so you can see here that I have a robot and I have the micro USB cable tethered from my computer into the robot, and that the robot is on, right? So here you can see, hopefully, that my screen is on. I'm going to come back, so I'm going to stop sharing that temporarily. And I'm going to share my Python editor. So let's go back to the editor. And I'm going to create a new project. So here I'm going to click on Create New Project. It's going to ask me what kind of project am I creating. So where we were working as a Mimic before, this time I'm going to pick the physical robot. So it just says VEX V5. If you were a VEX IQ person, you would click up here, or if you're a VEX EDR person, you'll click over here. And then my language is going to be Python. And for options here, it gives me a cute name, which is Sparkling Toy. Sometimes it's Whimsical Grass or Joyful Horse. let's call this motor spin. It's not going to do anything exciting. We're just going to make the motor move, and I'm going to hit create. Okay, so a couple of interesting things happened right away. Because I had the robot already turned on and connected to the computer, when I created that new project, it auto-populated with my motors and sensors. And so if I wasn't sure what motor 1 is or what motor 8 is, what those motors are controlling, what I can do right now is I can click this connect button, and I can move this little slider here to make the motor spin. So if I move, go back now to my sharing here. So let's just go and share my webcam so we can see what the robot is doing. So you can see that my robot on motor number 1 is it's actually spinning the right motor. And even though I'm telling it to spin forward, it's spinning in reverse, because what is happening here, if I disconnect, is that this motor happens to be upside down, right? So what we have happening is we have 2 motors, and it's going to be a little difficult to see. Let's see if I can get there. But you can see that this motor is actually mounted upside down. So when we're telling it to spin forward, it's actually going in reverse. So what we will have to do is we'll have to reverse the polarity of the motor so that forwards becomes backwards and backwards becomes forwards. Let's see how to do that. So let me stop sharing. And then what I'm going to do here is I am going to share my editor window. Okay, so what happened here is we saw that motor 1 was actually my right motor. So to make things a little easier, what I'm going to do is I'm going to call this motor right. And I'm going to make this a little bigger. I'm going to pull it so I can see what this is. My guess here, we said that the motor was upside down. So if I click on the little gear icon here, it's going to give me the option to reverse motor polarity, which means it's going to cause forwards to be backwards and backwards to be forwards. Thankfully, we don't have to think about that. Robot Mesh Studio does that for us. I'm going to hit OK. All right, so then we have some other motors here. And what I'm going to do again is I'm going to connect and see what they are. My guess here is that motor number 10 is my other motor. And now if I go back into my screen, my webcam, so let's share my webcam. We can see that we have 2 motors spinning. And if I come back into that screen and play with the claw, might be hard to see whether the claw actually opened or closed. It might be disconnected. But in this way, what we're doing here is it's just a way that we can do a mapping, right? So the motors by themselves with their port names is not a very useful descriptor. What I'm going to do is I'm going to disconnect and stop this. So let's go back into my, my programming environment. Okay. So what we had is we had a motor right. My motor 10 is actually my motor left. And presumably motor 3 is like my claw and my arm. I'm not going to be playing so much today with the claw and the arm just because I have a very real fear that my robot will come flying off the table. Okay. So what happened in that Python project is it created a bunch of objects, right? A bunch of things that are the different peripheral devices that plug into the robot. To make the robot move, so I'm going to take my, let's see here, let's make the right motor move forwards because that's the one we're going to be able to see. So I'm setting up my robot. So let's go here in the programming editor and type M. So now it's, as I start typing, if I type motor underscore right, see how IntelliSense is finding the object? And then I'm going to use this dot operator, right? Because I'm not sure what command would make my motor spin. So if I use dot, it's going to give me some choices, right? These are all the things that my right motor can do. So we can see if it's, you know, is it spinning? What kind of power? We can reset its rotation. If I go further and further down, we have an option to spin. So let's hit that. That sounds like the right choice. And then if I use the opening parentheses, right, because the spin method is going to need to have some additional data. For example, what direction to spin in and at what power setting should the motor spin. So here I'm going to open up parentheses, and now I get this little pop-up window that's telling me the kinds of arguments or the kinds of parameters that the motor is expecting. So it's going to say, this is going to turn the motor on and spin it in a specified direction and velocity if specified. So let's tell it, give it a direction. So I'm going to go VEX dot, and then let's see what my choices are here. So having done this enough times, I happen to know that the attribute I'm looking for here is direction type, and I'm going to go dot FWD. Now you might be saying, oh, that's you. It's sure it's easy for you. How did you know to find that? We'll see in a minute that I could have gone into Blockly and created a Blockly project and looked at the generated code. So just from experience, I've typed this out enough times in real life that I know the arguments it's expecting. It's going to spin forward. Let's make this spin at 25% power. And then we're going to have to set the type of velocity. So what units are we using? So are we going to spin in degrees per second, percentage of power, or revolutions per minute? I'm going to choose percent. So here what we're going to do is we're going to go motor right dot spin. The motor's going to spin forwards at 25% power. And let's run this program to see what happens. So I'm going to hit run. You can see it's compiling the program. And if I go into the other webcam here so that you can see what's happening, let's go to my sharing. Share. So let's just go to the webcam so we can see what the robot's doing. I'm going to play. Okay, so I just have, for anyone who's wondering, I just use this blue tape so I can see a little more easily from far away what direction my motor's moving in. It has no significance beyond that. So here I'm going to run my code, which was motor right dot spin at 25% power. I'm going to hit play. Okay, so what it did is it spun for about a second, right? But what if I wanted it to spin faster, or if I wanted it to spin for a greater duration? Let's make some changes in my program code so we can see how to do that. So let's go, I'm going to stop sharing this, and then I'm going to share my programming environment. Okay, so let's add on to this. For those of you who are coming from Robot C, in the Robot C world, there was the idea, I believe, of a wait command or a wait for command. In Python, it's called sleep. So what I'm going to do is I'm going to type sys.sleep. And what sys.sleep does is it holds the execution in the Python program until a number of seconds have passed. So what we were seeing here is that our motor spun, but it only spun for 1 second. What if I wanted it to spin for, say, 20 seconds? And rather than it spinning at 25%, at 25% power, I want it to spin really fast now. So let's make it spin at 100% power, and let's see what happens. I will go up here to run the program. If I did not want to be tethered to the robot, so say, for example, I want to have the robot drive on the floor, what I could do here is I could go on this pull-down menu and choose this download option. And what that will do is it will compile the program, transfer it to the V5 brain, but it won't execute the program right away. What will have to happen is I'll have to take out the micro USB cable, put the robot on the floor, and hit play. Alternatively, and this is unique to VEX V5, I can actually program the robot wirelessly using the V5 controller. And that's a really awesome option if you're lazy like me and you don't want to have to get out of your chair to keep chasing the robot. The only caveat to using the V5 controller is if there's too many people in too small of a space all programming using the wireless option through the V5 controller, you will get lots of dropped connections. So for those who were at Worlds this past year, you probably remember them saying, please turn off your cell phones, don't create hotspots and all of that every couple of seconds. And that's because you had all of these kids and all of these teams doing wireless programming in the same space. And so all of those controllers are fighting for the same limited amount of radio bandwidth, which is causing people to drop. So if you're just programming the robot by yourself and you're lazy, using the V5 controller is awesome. If you're working in a larger classroom setting or in an environment where there's lots of other competition teams, I typically use the micro USB cable. So I just wanted to show this, that's one way I could transfer my program without executing it. Because I am connected and I have my robot mounted on the table, I'm just going to hit run. We'll see what happens. So before I hit the play button up here, I'm going to go into the camera so we can see what the robot does. Okay, so now here's my robot, and I'm going to run that program that spins my right motor at 100% power for 20 seconds. So you can see it spinning much faster, right? And what I'm going to do is 20 seconds is a very long time, so I'm going to hit the stop button to stop the program. And I'm going to come back to my my program editing environment in Robot Mesh Studio. And say, for example, I wanted to have both motors spin at the same time. Well, I could go motor, and now it's going to show me my options here. So see, I have a motor left, dot spin. And then maybe I want the left motor, for whatever reason, to spin in a different direction. So it's going to spin in reverse. And it's going to spin in reverse very slowly. Perhaps my robot is making some kind of a point turn. So let's just say it's going to spin at 25% VEX velocity units, and then dot TCT. So let's go back to the webcam so we can see what the robot does. And I'm going to hit run. So now you can see, if I pull this, stop. I have a little piece of tape on the other side, which might be difficult to see, but we're going to see that this spins a lot slower, right? Because I said for it to move at 25% power. And it's spinning in the opposite direction, which I also told it to do. Okay. Now, some of you are asking, how might I have done this in Blockly, right? Because this Python thing is a little overwhelming at this stage of the game. So what I'm going to do is I'm going to stop sharing this. I'm going to go back to my programming environment. And I'm going to go up here to options, and I'm going to copy this project. Now, interestingly, if you have a Blockly program, it will generate the Python code, but you can't go in the reverse direction. So my Python won't become blocks. I'm going to have to rebuild it. Fortunately, this is a very small program. The benefit of copying the project is it's going to remember all my settings here. So what motors are in which ports. So I'm just going to go options, copy project. And this I'm going to call Blockly motor spin. I'm going to change my type of project from VEX V5 Python project to VEX V5 Blockly project and hit OK. You'll notice that I can't copy the code. It says exporting code is not supported between project types, but that's OK. So let's rebuild that as a Blockly program. So here I have a generated code window, which I'm just going to anchor so we can see the code that's being created. And what I'm going to do here is it remembers my motors. So what I'm going to do is I'm going to go into the motor library, and I'm going to choose this motor spin. And you can, if you watch on the right-hand side as I configure this, it's going to say, what motor do you want to spin, right? There's this little exclamation mark. I'm going to say, I want my right motor to spin forward at 100% power. And that's exactly, if I step out a little bit here, so let's close this so we can see our code. That is indeed what we had written in the other project. So now let's add another block. I'm going to come up here and say, I wanted my left motor left to spin in reverse at 25% power. Recall that we had that motor moving much more slowly. And then I want both of these motors to do that for 20 seconds. So up here in the Robot Mesh library, I'm going to find this sleep for block. And rather than 3 seconds, I'm going to make it 20. And let's run this program and see if it does what the old program did, which I hope it does. So let's go back to my camera. So I'm going to hit play to run the Blockly program. And that is indeed the case. I'm going to stop that program and come back to my Robot Mesh Studio window. Okay, so imagine this, that you didn't know what those commands were, right? So I could have built the Blockly program, see what Python is generated. You'll notice that I cannot edit the code inside this Python window. To edit this code and change it as a Python program, I'm going to have to come back up here to the options menu and choose my project. One other thing we have not discussed is I can set the visibility of the project. So right now, all of these projects are private to my account. If I wanted to share a project, I can make it public. As a word of caution, when I make the project public, it is public in the real sense of the word to the whole world, which might not be ideal if you are a team. Robot Mesh does sell a classroom license, which allows you to manage closed groups of students. And if that's something that's interesting, you can get a hold of us at sales@robotmesh.com, and we can show you how to go about purchasing that if that's interesting to you. You'll also find it, I believe, in our web store at robotmesh.com. So we can change the visibility. I'm going to keep this a private project, and my copied project is now not going to be a VEX v5 Blockly project. It's just going to be a VEX v5 Python project. And so when I hit OK, that window disappears, and now I can change things, right? So maybe I do want this to change at 100% power or do whatever. What I'm going to do right now is I'm going to hang out here for a couple of seconds, see if there's any questions. The next topic I'm going to discuss is drivetrains, right? So if you're going to be moving your robot a great distance or navigating it around obstacles, like in this year's VRC challenge, it's going to become very tedious to have to coordinate individual motor movements, and we can use a drivetrain to move multiple motors at once. So that is my very next topic. Right now, what I'll do is I'll just hang out here for a couple of seconds, and I'm going to take a quick peek at what's happening in Facebook, and if there's any questions, I will do my best to answer them live right now. Okay. Wendy asks, what does the competition format look like? Also programming the robot's joystick. Okay, excellent. Let me come back to that. So I'm going to leave that question up. I'm going to talk about drivetrains just because I've done all of the work to have a drivetrain, and then we will talk about controller-based programming and the competition template. So hang on a second, Wendy. I will come back to you. How would the process be different if you're using VEX EDR? What you may find is in a VEX EDR project, some of these commands are a little different. Let's just take a quick peek. I'm just going to privately open up a window here and see if I can do a satisfactory job of answering that question for you. I personally don't have as much experience with the old Cortex, but I know that the workflow is going to be very similar. So let's just change this to VEX EDR. So I can see for the VEX EDR that I have the same two choices. I can program it in Blockly or Python. I'm going to pick Python. Now, because I do not have a Python, I do not have an EDR robot plugged in right now, I'm not going to be able to do this. In fact, I'm not sure. Can I create an EDR mimic? I can create an EDR mimic. I'm going to try and do this as a simulation file and cheat a little bit. So let me make sure I'm in my screen share here. I'm just going to come back and make sure I'm sharing the screen. Yeah, I am. Good. Okay, so what I did is I created an EDR mimic. You'll recall that the ports on the EDR are what I like to call dumb ports. So what's new to V5 is a lot of the motors and new sensors that will be coming out for the V5 in the future have little computers built into them. So what happens is when the robot is turned on and plugged into Robot Mesh Studio, the software will usually find those devices. Using the old 3-wire ports, we have to manually add them. So here on D1, if I click the little gear icon, what are my choices here? And this is where my ignorance on EDR is going to be a little different. So here on the M1 through 9 ports, here's my old 393 motor. I'll hit create. And what it did is it created a motor. So now if I type motor _1 dot, and now see, you can see how the commands are different. So because the V5 smart motors are smart, there's a lot more things we can do with them. Here, I just have the option of run, right? So run, and then some parameter, whatever it is. Okay. Again, this is probably, if this is a topic that's interesting to you, I would encourage you to go to forum.robotmesh.com. So I'm just going to throw that into the chat window. And if you ask that, one of our more experienced EDR guys will take a look at that question, because we have lots of EDR Cortex experience. I'm just not that guy. So here in the chat window, I've given a link to the forum, which is just forum.robotmesh.com. And if you throw your question there, someone will get back to it. Okay, let's go and come back to my V5 project, and I'm going to create a drivetrain, right? So this would be a little tedious having to coordinate individual motors. What I could do is I could go down here to the drivetrain library and click this gear icon. And it's going to say, do you want to configure a drivetrain? Yes, I do. It's going to say, what is your left motor? My left motor is my motor left. So this is where giving your motors a good descriptive name is useful. What is your right motor? My right motor is my motor right. I'm going to accept the defaults for wheel travel and track width. Basically, there's some math that is happening behind the scenes in Robot Mesh Studio so that the robot moves the correct distance. So that's a reflection of the wheel width and the amount of distance between the two wheels. If you start changing these values, you might see some funny behavior. If your robot is anything other than the V5 Clawbot, so for example, perhaps you have a wider driving base or a narrower driving base, you may have to find that you have to toggle these numbers to get the right kind of movement behavior. But for now, because I am using the default VEX Clawbot, I'm just going to accept the defaults here. You can see that it has reversed polarity for me, which isn't a big deal. If I've already reversed polarity, it will just ignore my first reversal, so don't get stressed out about that. Hit OK. And now I have a drivetrain object. You can see here it says DT. So rather than doing this, I could comment this code out, right? So for those who've worked in other programming languages, you know that commented code is not executed by the interpreter or the compiler if you're using a strongly typed language like C. So up here, there's a little hashtag, and it says toggle comment. And when I do that, what I've just done here is the Python interpreter, as it goes through my program, is going to ignore these lines. So instead of using right motor.spin and left motor.spin, what I could say instead, and I'm just going to give myself a little more real estate, is I could go DT for drivetrain dot drive. So you see I have all these different choices, right? Start drive, start turn, stop. So here I could go DT dot drive. And then it's going to want to know what direction am I driving in and how fast am I driving in. So here I might go VEX dot direction type. And this just comes from experience from using IntelliSense and Blockly. So you'll get a better handle on these attributes as we go forward. So VEX.DirectionType.forward. So it's going to spin, say, at 100% power. And the type of velocity unit we'll use this time will be VEX.VelocityUnits. Let's make it degrees per second. I have no idea what will happen. So it's going to spin 100 degrees per second for 20 seconds. So now what we should see is both wheels, both motors turning at the same time. So I'm just going to set up my webcam so we can see this. Okay, so let me share this. Okay, so now I have a drivetrain that's going to spin both motors at 100 degrees per second. So hit for 20 seconds. So I can hit run. And as we can see, 100 degrees per second is very different than 100% velocity. So that's actually quite boring to watch. I'm going to hit the stop button, and in the Python editor, I'm going to change that degrees per second to percent power. So we see a much more dramatic change here. I'm going to rerun that code. So now we can see that we're really hauling butt here. We have both motors spinning very quickly. I'm going to come back to my Python editor. So let me come back to Robot Mesh Studio. Just hang on a second. Okay. So what I could do now is say, for example, I wanted the robot to drive at 50% power. And then maybe I want something like the robot to turn. So it's going to say turn left 90 degrees. So we go DT. And what are my choices here for turning? Oh, I saw turn. So we could go turn 4. And then what arguments is it expecting? A turn type and an angle. So I could go VEX dot turn type dot at left or right. So let's say it's going to go left, and it's going to turn 90. So now you can see that the blue part angle has highlighted 90. And then I can specify 90 what unit. So I go VEX dot, I think it's rotation units dot degree. Okay. So it's going to drive forward, and I'm just going to change these the placement of these sleep commands so that we can observe the two behaviors. So let's make this a little shorter and go sys.sleep for 5 seconds. So it's going to drive at 50% power for 5 seconds, and then it's going to turn left, let's say at sys.sleep for 10 seconds. We can see what it's doing. And I'm going to run this code. So I'm going to go back up here and I'm going to hit run. Let me go back to my camera so we can see what's going to happen. Okay, so here I'm running my code. The first 5 seconds, both motors are spinning in the same direction. We can see the tape traveling. And now you can see that change, right? So the two motors started spinning in different directions. Let's see if I can be a little more dramatic about this. I'm going to change my code. So rather than turn 4, it's just going to be a vanilla drivetrain.turn. And so let's go drivetrain.turn, vex.turn type, let's make this turn left again. And let's go at, I don't know, 100. Let's make this turn really fast at 100% vex.velocity units, vex.velocity units. Percent. So I'm aware that you cannot see the code right now. I just was lazy and changed it here privately on screen. I'm going to hit run. So let me go into my webcam here so we can see that our two pieces of tape are aligned, and it's going to spin slowly for 5 seconds, and then we should see the wheels spinning in different directions very quickly at 100% power. See? So my one wheel is spinning backwards, my left wheel and my right wheel is spinning forwards. I'm going to slow that down to like 10% so we can see that what's actually happening here. So both motors spinning at 50% power for 5 seconds, and now you can see that one tape is going the other direction, this piece of tape is going this way, so my robot is making a turn. Okay. If I wanted to work with things like the robot's arm and claw, I might be inviting disaster to step in here, but we'll just see what I can do with the arm. So I'm going to remove this code. And I might do something like motor claw. I hope this is the right port. I haven't really tested it. Dot spin. And now I might try and make this open really slowly so I don't destroy my claw. Velocity units. So we will make this spin for like, I don't know, 2 seconds. So what I'm going to do here is let's go back into my webcam and see what happens here. So now rather than playing with the wheels, we're going to play with the claw. So you can see I've closed the claw. Let's see what happens when I run this command. Okay, something happened. I can hear the motor. So what happened is the claws came together. They were already together, and I could hear the motor stalling. So that means that traveling forward is not the right direction. What's going to have to happen is the claw is going to have to spin in reverse. So I'm just going to change this to reverse and run my code. We'll see what happens. Oh, much better, right? So now I could go back. So let's go back to my editor. So now I had this going in reverse at 25%. I could go something like, maybe it's going to hold for 2 seconds, and then it's going to go motor dot claw, motor claw spin, and it's going to spin in the other direction, right? So it's going to close. Okay. And so it's going to do that, say, for 2 seconds. Awesome. Okay, so opens for 2 seconds, closes for 2 seconds. Let's see if that works. And then we'll hang out for a couple of seconds to see if you have any questions. Okay. Okay, so I'm going to close my claw and I'm going to run my code. Let's see what happens. Okay, so it's going to open for 2 seconds. That's going to close for 2 seconds. Okay. So that's motors and movement. I'm going to hang out here for a second and see if there's any other questions, and then I will come back to Wendy, who asked about programming the joystick and the competition template. Okay, and while that's happening, I'm just going to temporarily see what's going on in Facebook land, just to not ignore the rest of the population. So let's just see what other questions we're seeing here on Facebook. Okay, yeah, so far no new questions. Again, if you happen to be watching this on Facebook, I will be posting all the links that I use to the different projects and Python resources onto the page. Okay. All righty. Another couple of seconds, and then we will move on to talk about joystick programming. Okay. All right, well, if you do have a question, you can always ask it. I will eventually come back. Let's move on to talking about the joystick. So I'm going to stop sharing my webcam, and I'm going to share my screen. Okay. So there's a couple of ways that I can create, program the joystick. The easiest way by far is using the wizard that's Controller Express in Robot Mesh Studio. So maybe what I might do is I'm going to come back up here to my projects. And while that's loading, I'm going to hunt around behind me for a VEX V5 controller. So I'll just give me a minute here to see if one exists. I did at one time have a controller. So we'll see if this works. Okay, so I did find a controller, and I'm going to wing it a little bit here. So let's create a new project. My target platform is going to be the physical VEX robot. Again, if you're an IQ person, it's going to work the same way. You just pick IQ, choose language, and you'll notice there's an option here called Controller Express, and I'll hit select. So Polite Football is as good a name as any. I'll hit create. Okay, so now what we can see is we get this picture of the V5 controller. If it's an IQ project, the controller is going to look a little bit differently. It uses different channels. And here we can see that channel 3 is our left joystick up and down, and channel 2 is our right joystick up and down. So if you have a preference for arcade drive or tank controls, you can pick one or the other. I happen to have a bias towards tank controls, so that's the way I'm going to do this. But here I would see where it says access to. Notice that my robot is plugged in, so it found all the motors. It did not keep the names from the last project. So if I wanted to, I could go through this exercise of renaming everything. I'm just gonna leave it as motor 1 is being my right motor and motor 10 being my left. So right now I'm gonna go to add action. It's gonna say, what do you want to do? I want a linear control, meaning that when I press the joystick forwards, it's going to spin the motor one way. And when I pull the joystick back, it's going to spin the motor in the other direction. So here I'm going to have linear control, motor, and then my motor. What is that button going to control? On axis 2. So I'm sorry. So let's change this around a little bit because that I believe was my right mode. Let's just see. Now this is where you get confused, where it's like, ooh, which motor am I using? Let's just say it doesn't really matter right now. So axis 2 is my right joystick. I believe motor 1 is my right motor. Axis 3, linear control, and then I'm going to make it the other motor, which I think was motor 10. And then there's some things I'm going to have to do because I just grabbed a V5 controller out of a bin of V5 controllers. So what I'm going to do, what you can't see right now on camera, is I'm just going to pair this controller to the brain. So let me show you that. Okay, so I have my V5 controller, and I'm just going to turn my VEX robot on because I see that it went to sleep. And hopefully my battery didn't die because that would really suck. Ah, my battery's dead. All right, well, I have to suspend disbelief then. So what I would have done here is I would have paired my controller to the robot, and you can just grab one of the ports here so that my controller finds the robot. What will happen is when your controller is paired, the red radio will begin flashing, meaning that it's paired, and you'll also see an icon up here. And then what happens is I will go back to sharing my program window. So here, after I've done this mapping, I might hit run. You could imagine that I might want to assign other buttons to open and close the claw and lift and lower the arm. So what I might do is my L1 and L2 buttons, for example, might be that when you press it forward, it's going to move the claw. I think motor 3 is my claw at, say, 25% power. I don't want it to open up so quickly that it destroys the motor. And then maybe when I press on the L2 button back here, it pulls the motor in the other direction to close the claw, right? So now it's going to go in the other direction, reverse, I'd say the same power. And then for my right buttons here, I'd do the same kind of thing. So, this is now going to spin in forwards, and this might raise and lower the arm on the robot. And maybe I want that to happen a little faster at 50% power. And if I pull this in the other direction, then it's just going to lower the arm. Okay. So when that's all mapped, you basically go through that exercise, you hit the run button up here to run your code, and you'll either love the way your robot runs or you'll really hate it, and then you'll have to come back in here and change it again and again. And then the last part here, which I went into greater depth in our previous webinar that exists on our YouTube channel. The competition template, in my opinion, is the easiest way to generate code for the autonomous section of the contest. I'm just going to go into my projects. Create a new project. So again, my VEX V5. Of course, the VRC is the only is the only platform that uses the competition template. My language, so I probably could create it here as a Python project. And here you can say use VRC competition template. Now I'm more comfortable doing this using Blockly, but again, Blockly generates Python. So here I use VRC competition template. And what you can see now is I have these 3 functions, or these 3 places to place blocks. I have my autonomous behavior. So say I'm just making this up right now. Maybe what's going to happen is, I don't know, the robot in autonomous, the robot's motor is going to do something. I'm just making this up. So this might be, my left motor is going to spin forward for 90 degrees. And then, I don't know, my I might have a drivetrain that does something weird. And so you can imagine that all of this code executes during the 15 seconds of autonomous. Then the driver control portion of the match. So here again, I might put blocks inside of here. So I'm going to print hello. Maybe I'm going to have some buttons on the controller mapped to specific functionality. And I just build it like that. In the generated code, you can see that this is just a Python template. So now what I could do if I wanted is I could copy this project as a VEX v5 Python project. And of course, because I don't have any motors selected, I'm not plugged into a robot right now. It's going to give me an error. But again, had I gone back here and created a project, v5, this time it's going to be Python. And you see that I have the option to use VRC competition template, hit create. And now you can see that those functions exist as Python functions. So hopefully that's helpful. Again, on our YouTube channel, youtube.com/robotmesh, which I'll just throw into the old chat window, we have actually a playlist called Competition, and the lovely John Tyler goes through and explains how to use this in greater detail. So let's say that that is done. Where do you access this video if you want to start from the beginning? Again, YouTube is going to be your friend. I would suggest to you that you take a look at our YouTube page at the end of day tomorrow. There's going to be a playlist called webinars. And again, actually, if I just show you where it lives on YouTube. So let's go to youtube.com/robotmesh. If you become a subscriber, again, my selfish little pitch here, we're not going to watch any videos here. But if you become a subscriber, then you'll get a notification when new videos get added. But what we can see here is I have a set of playlists. And I have a playlist called webinars. So if I go view full playlist, what we'll see is that this session will wind up here somewhere. Obviously, this has been a very long webinar. We've covered a lot of material in a very short time. So the Python snippets, there's actually a Python playlist. I've called it Python Like a Pro. And over the course of the next few weeks, there'll be little 2- and 3-minute videos on different topics that are coming up. If you have an idea for a specific topic you would like to see addressed, join our YouTube page and add it as a comment to the video, and I'll see if I can help you out. Any last orders of business here that I need to talk to you about in my PowerPoint? So I'm just hunting through. So I'm just going to go through these last few slides very slowly, or very quickly rather. So we haven't talked about braking, but there's basically 3 styles of braking, which is the motors can brake, meaning that they temporarily lock up, but not hold the position. We can also tell that we want the motors to coast, meaning that what will happen is that when the command is finished executing, the motors will just lose momentum. So that it's kind of like taking your foot off the gas. And then finally, we have motor hold, which when I hold the motor, what's going to happen is if I try and move it, move the wheel that's attached, the V5 motor is going to fight to maintain its position. So we'll just take a look at some quick code examples here. So to use the stopping functionality, we use .stop. And then our choices here are going to be vex.brake type. And you can see I have choices here of brake, coast, and hold. I do not recommend choosing undefined. That's probably something that should go away in a future version of the software. And so what we might do in this example is we had our left motor spinning at 50% power for 3 seconds, and then it stops. And what we've done is we've said brake. And so you've noticed that brake is in all caps, and that's because brake is what is known as a constant. A constant is a memory placeholder, much like a variable. However, unlike a variable, its initial value can never be changed by the program. So examples of constants in real life are the temperature that water boils at, the temperature that water freezes at, pi. These are numbers that are never going to change and can never change. So they are constants. Constants in code are denoted by these words that are in all caps. We can see here that forward is a constant, percent power is a constant, and brake is a constant. And so now we've talked about drivetrains. I would like to give you some next steps. So if something that you saw today is exciting and you want to know more about Python, I'm going to post some links right now to various books on generic Python. There's going to be some videos and stuff added on the Robot Mesh site, which is curriculum.robotmesh.com. I'm just going to update. I'm going to send a URL here into chat. Curriculum.robotmesh.com is where our online lessons live. We've talked about our YouTube channel, which is youtube.com/robotmesh. There will be some generic Python stuff in there, but most of our work that we do with Python is going to be focused around the specifics of working with the VEX robot hardware. If you're looking for some really great books to read on Python, I'm going to post some links in here. One of them that I really liked, and I could see this being very popular with students, is a book called Python for Kids. It exists in a variety of formats here. You can get it in hardcover or online, I think, through Amazon. I also have another book that's a very easy read called Learn Python in One Day and Learn It Well. So here I'm going to copy that, and I'm going to post that link into the chat window as well. And both of them are pretty easy reads. You can probably read either book in probably a day. So if you sat down on a Sunday, you would know it reasonably well. And then you would just have to focus on learning the little bits of VEX-specific Python to control the motors and sensors. We didn't have time to get into sensors today. I want to perhaps do it as a future webinar topic because there's a lot we can do there, not just in Python, but with other languages and within the Robot Mesh Studio tool itself in terms of data logging. So what we will, where I will leave at things right now is I will stop right now to conclude the presentation. I'm going to hang out here for a couple of seconds to answer your questions. So if you come up with questions later on, you can go to forum.robotmesh.com. And again, I'm going to post this in our web form here. Forum into the chat is just forum.robotmesh.com. And if I don't have the answer, somebody at our office definitely will have the answer. So it's a great place to go. And that is it for this webinar. I've enjoyed having you. If you want to hang around for a couple of seconds to ask questions, just raise your hand. There's a little button. And then what will happen is I will know that you're typing something, and I will look into the chat window to see what it is that you would like to ask. If not, again, this video will live on both our Facebook page and on YouTube. So thank you, everyone. I'm going to stick around for another minute or two to see if anyone has any questions. Hit the little raised hand icon in your little Zoom webinar tools button so that I know that you're typing something. Okay. Somebody has asked, would you have to pay for the software to access this offline, say at a competition? Robot Mesh has a desktop version of the software that runs completely offline. What I might do right now is just show you where that lives. So whenever possible, I highly recommend people use the online version because it tends to get updated with bug fixes a lot more frequently. The desktop version is stable, so you can use it. It's just, it tends to be a version behind. It's been my experience. If I go to robotmesh.com/studio, let's make sure I'm sharing my screen here. Okay, you can see there's an option here, work offline with Robot Mesh Studio Desktop. And if I give that a click, there is a Windows version of the tool and a command line utility that you can use. I'm going to see if I actually have Robot Mesh offline installed on this machine. It appears that I do not have Robot Mesh Studio offline, but basically the way Robot Mesh Studio offline is going to work is when you open up the Windows application, if you have an internet connection, it's going to try and log into the internet and pull down your projects. If you do not have an internet connection, you can create local projects that live on your computer. And then when you're finished and you do get an internet connection, eventually you can upload those projects back online. So again, I hope that helps. Let's just take a peek and see what other things are going on here. I'm going to temporarily stop sharing. Okay, so I still have 3 attendees left. I'm going to hang out for another minute or two, and if you have a question, now would be a good time to ask it. Otherwise, I'll get back to you on the forums. Okay. Well, I'm going to take your silence as that you are saturated with knowledge and that you have no questions to ask. Again, if you came up with a question a little later on, forum.robotmesh.com is a great place to ask it, or on Facebook, if you're a fan of our Facebook page, you can do so in the comment section there. All right. Excellent. Thank you, everyone, for joining me today. Have a wonderful Sunday. Take care.